Hi, everyone, and welcome to the MLOps Live webinar series. My name is Sahar, and I'm Iguazio's VP Marketing. It's great to have you all with us today. As most of you know by now, this series of webcasts is all about operationalizing machine learning and bringing data science into real business applications. And today, we're going to be taking a deep dive into a great use case. This use case is all about building an MLOps infrastructure that works at scale and in real time. NetApp's ActiveIQ provides insights and optimization of storage controllers owned by NetApp's customers around the world, and also runs predictive maintenance by gathering insights from 10 trillion data points per month globally. This is an incredible project, and to explain to us how this was all done, we're delighted to have Shankar Pasupathy with us today. Shankar is the Chief Architect and Senior Technical Director for ActiveIQ at NetApp, where he's been leading both the data engineering and AI teams for the past 6 years. Prior to ActiveIQ, Shankar was a senior manager in the CTO's office and has published over 40 patents, a dozen research papers, and received several NetApp Innovation Awards. He'll be joined by Iguazio's co-founder and CTO, Yaron Haviv, a serial entrepreneur who served in multiple CTO roles before starting Iguazio, and also created Nucleo, a leading open source serverless platform with over 3,000 GitHub stars, and MLRun, Iguazio's open source pipeline orchestration framework. We'll start off with a quick intro to MLOps. Then we'll discuss how NetApp built their solution, migrating from Hadoop to a microservices Kubernetes serverless environment, and adopting an agile and hybrid approach to development and deployment. Later in the session, we'll see how serverless automation and MLOps practices accelerate time to market and cut costs for AI projects at scale. We'll be answering questions throughout the presentation in the Q&A panel at the bottom of your screen, and we'll also take some questions at the end, so feel free to type them in to the Q&A box. We'll also be running a short 2-question poll during the session. It is completely anonymous, so please do fill that in so that we can make these sessions as valuable as possible for you. We've put everyone on mute, and the session will be recorded and sent to you after the presentation. And I will now pass it over to Yaron to get things started.
So thanks, Sahar, and hi, everyone. Just before we move into Shankar's use case, which is very exciting, very large scale, and also at the business level is going to introduce the impact that they've made on the business. Let's talk a few words on the architectural stuff and MLOps. Next, Sahar. So what is really MLOps and what is this all about? So we know that when data scientists build solutions, it's essentially starting in a lab, in a research facility, where they take small scale data, usually in the form of CSV files or Excel spreadsheets, and then they work to analyze it, identify features, followed by training and generating models. But usually this exercise is done on notebooks where it's not really designed for production. And at a later stage, once things are ready and sort of baked, there's a different team that builds it into a production pipeline, like the one that Shankar is going to show us, where data is actually live. It's feeding from lots of sources. Some of the sources could be live databases where you need to do ETL. Some of them would be streaming solutions with live transactions, location updates. Some of them are APIs, internet, or in our application space. All of that is feeding into sort of this pond that you denormalize, you aggregate, you build those interesting features, but usually in an automated and scalable fashion, followed by running training and machine learning, and then doing front-end applications or serving, so model serving, dashboards, alerting, all of that based on this information and the insight that we generated and the model that we generated. And we're going to see a very exciting use case from NetApp, how they essentially pull tons of data, really massive amounts of data into a relatively small cluster, crunch it, build models off of it, and take those models to actually create a customer experience and predictive maintenance, which saves a lot of money for NetApp and a lot of aggravation to the end users and the customers. Next. So essentially what they've built is a pipeline. This pipeline is collecting data from different sources, files, streams, etc. The data is again being sort of aggregated and normalized. It's using a special technology from Iguazio, which is a very high speed, high density analytics time series database, which is essentially taking all those different time oriented data points. And we also have a key value there that is aggregating all the picture. And this picture is then ready for processing by whether it's machine learning tools or just dashboards that take that and visualize that to the user or alerting mechanism. So the idea is collecting all the data, pushing it into a layout which is very organized in time series manner, running various training and aggregations on top of it, and building interesting dashboards and alerts based on that thing. Next. So the alternative that the NetApp team was using, and Shankar is going to describe it in more details, was Hadoop. And Hadoop was the first thing they've built off, not as ambitious project as we've just shown with real time and all of that, but it was mainly batch oriented. And this is where many organizations today, they've built large Hadoop clusters. Those Hadoop clusters are usually running in a batch form. They're not as integrated to the rest of the ecosystem, which is now evolving with microservices and Kubernetes and cloud services. So you end up first having sort of a technology which is relatively ancient and also not so flexible. So what we've seen today in the world is the move from Hadoop, which is essentially 3 different layers, 3 different tiers. The first tier in Hadoop is HDFS, which is a relatively limited file system. And also it duplicates a lot of data and it's not so efficient. On top of it, sometimes we have various databases like HBIS, which were also used by NetApp. On top of that, you have a scheduling system called Yarn. And today with the modern architecture, you have new scheduling system and new orchestration systems like Kubernetes, which are much more advanced and cloud native. And on top of it, you have a few application stacks, which are very specific to data processing. Some of them are already sort of rest in peace, like Pig and MapReduce. Some of them are still live and kicking, like Spark and Presto, but those can also run on a Kubernetes cluster. So the migration today is from those relatively complicated, relatively batch-oriented setups to a stack that looks like the one on the right. So having sort of a managed storage and managed databases, whether they're in the cloud or on premises, like the NetApp storage systems. On top of it, you layer a Kubernetes cluster, which is scheduling all those microservices, which are not now constraints to the traditional Hadoop workload. So you can run the Hadoop workloads like Spark, Hive, Presto, side by side with TensorFlow and serverless functions and Kubeflow and all those different frameworks all on a single cluster. You don't have to separate your work to 2 separate clusters. And the nice thing about having more and more managed services, whether it's on the Kubernetes side or the data side, is that you can focus more and more on your business logic and you could innovate faster. And this is essentially what we're going to see. Next. So without further ado, then we'll move to the next presentation from Shankar. And there is a question here for the poll.
Yes, we'll just do a quick poll and we'll pass it over to Shankar. So please do take part in this poll. Where are you on your MLOps journey? We'll just give it another 5 seconds for everyone who still wants to vote. And last chance to vote. Okay, thanks everyone. And we will be showing the results at the end. Over to you, Shankar.
Thanks, Sahar. Hello, everyone, and thank you for joining today. I don't know if Yaron remembers, but it's almost going to be a year since I first contacted Yaron and Asaf. I'd heard about Iguazio from others, and I said, this looks interesting. We need to think about using it. So we actually started a POC in July last year, and now we've gone to production with this. So I'm going to walk you through our journey and why we started doing all of this. Next slide, please. So first, I want to give you some context for what it is we do, what is ActiveIQ, and why all of this is important to us. We collect telemetry data from all of NetApp's storage systems around the world every single day, and we get approximately 10 trillion data points per month. And this data is basically three kinds of things. It contains configuration information about the storage system itself, which we then use to optimize customer setups. It has a lot of performance data, which can be used for a variety of things. And lastly, it has logs, events, significant events that have occurred, which we can then use for predictive maintenance, like, for example, predicting when a disk is about to fail, or predicting when a network card is going to fail, things like that. So these three kinds of information arrive to us every single day. And the key thing is, obviously, this is time series in nature, right? We have to look at it over time. And that'll become important later as we talk about this. All of this essentially feeds our platform. We call it the ActiveIQ data platform, which has a lot of different components, but at a high level, it's roughly a 5 petabyte hot data lake. That's information that we mine on a fairly regular basis. It represents roughly about 2.5 years of data. And we also have 15 petabytes of archival data. And we actually had one occasion where we had to go back many years in time and use that. We then mine all this data for insights and make that available to our customers through one of three means. There is a desktop application called ActiveIQ, a mobile version of that's pretty popular. And increasingly, customers are telling us, just give us APIs with your insights, and they feed it into their own tool chains. So we make that available as well. Next slide, please. So you might wonder, what's the point of ActiveIQ? So we have looked at data over many years, and can we go back to the previous one? Yeah. So we've looked at data over many years, and we found that the customers that use ActiveIQ, they have far fewer P1 cases, right? Far fewer disruptions. In fact, ActiveIQ has saved more than 2 million hours of potential downtime over the year across all our storage systems. So it's pretty significant. Now, could we go to the next slide? I briefly want to talk about the AI part of what we're trying to do. In this webinar, we won't go into the details of what we do. It's pretty high level, but if you're interested in details, you can contact us offline. See, at a high level, what's going on is in the traditional enterprise storage system, you have a storage admin who's getting requests about creating storage for a particular application. Let's say somebody wants to run MongoDB within the enterprise. It's the storage admin's job to then provision that storage, to decide what kind of storage to use, how best to configure it, and make sure that the application is getting the SLAs it needs from storage. And it turns out this can be a fairly complex problem. And your typical storage admin is relying on things like technical documentation, Stack Overflow, and even experience to decide how best to provision storage. What we're basically trying to do here is use the power of all this telemetry data we gather to make recommendations about how best to optimize your system. So there's two parts that we do. One that we already do today, which is predictive maintenance, predicting when a disk is going to fail, predicting when other parts of your system are going to fail, and remediating that before a failure occurs. And we do that pretty well today. The other aspect is, how do you optimize your systems to get the best out of it for particular applications? And those are things where we're actively using AI to do this work. Okay, next slide, please. So what are some of the challenges in doing all of this? One of the biggest challenges we have is, and it's actually a good challenge to have, we get a tremendous amount of data, right? 10 trillion data points a month, and that number is going up very, very fast. In about 18 months, we might be double that number. Also, the velocity at which this data is arriving is getting smaller and smaller. In other words, we're trying to go more towards real-time event-driven processing. And then the variety is also increasing because we're trying to gather data from more sources beyond just storage to give people a holistic picture of what's going on. So as a result of all this data we're getting, we have three sort of subsequent challenges. The first is we need to convert that raw data into deep insights for our customers really fast. That's what I call time to derive insights. The second thing is, if we built a successful machine learning model, we need to deploy that into production very quickly, right? Or it may be something as simple as producing APIs that make this data available to our customers, and we have to do that really fast. So time to market, time to deployment is another challenge. And the last significant thing that everybody seems to have is the cost of this operation, because the cost of people cost, software, hardware, they don't grow in proportion to the volume of data we receive. And this is something we need to manage effectively. Next slide, please. So I want to describe to you what we have done with Iguazio, but before that, I want to start with the outcome that we've achieved. Essentially, by replacing our legacy Hadoop stack with a solution built on top of Iguazio and NetApp storage, we have achieved a 50% reduction in operating costs over a 3-year period. And it's driven by a massive storage capacity reduction that I'll explain, far fewer compute nodes. And lastly, we're able to now deploy new services significantly faster than we could in our legacy architecture. And next, I'm going to describe all of this. One thing I do want to point out is in this talk, I'm mostly going to be focusing on the data prep part of the MLOps flow. See, there's the data prep part and then the machine learning, building the machine learning models and deploying them to production. So in the interest of time, I'm not going to focus on the latter two, that is the machine learning models themselves, but I'm going to focus on the data prep part, which is very significant for us. Next slide, please. This is a view of our legacy data pipeline. The real picture is horrendously complicated. Okay, so I've tried to simplify this greatly. But essentially, we used to have 3 sort of Hadoop clusters, one for event processing, a Spark streaming-based architecture on HDFS, a batch cluster, and lastly, HBase that stored all our performance counter data. And we would then take all this incoming data, which fed into Kafka, process it in one of these 3 Hadoop clusters. And in reality, there were more Hadoop clusters, for POCs, QA, pre-production, and so on. So we actually had quite a few Hadoop clusters. And we would then take all of this data, transform it in these clusters, and write the output to a variety of key value stores. And we had quite a few of those, Cassandra, MongoDB, and so on. We also had some SQL for legacy reasons, and a Solar Cassandra cluster for full text search. And it's the right side of this picture that was used to drive our APIs that fed into the UIs, right? So this is the legacy architecture. And I want to now dive into 3 specific problems we had with this. Next slide, please. The first challenge is that on-premises Hadoop is actually quite complex and costly to manage. See, there's a bunch of people that use Hadoop at large scale, and they sort of manage it on their own without paying anyone for that, right? Just essentially open source. But if you go look at the bulk of the enterprise customers, they're actually paying someone to maintain their Hadoop cluster. They're buying some sanitized version of the software from someone. And at scale, this starts to get really expensive, right? And you all know that with the Hadoop file system, you're making multiple copies of the data. You also end up having multiple clusters. And so now you have the same data scattered all over the place. We found that with the traditional Hadoop architecture, the CPUs were not utilized very effectively. Right? The ratio of productive work you're doing to the amount of CPU using is actually pretty low. Anybody that has done upgrades of this stuff on premises knows what a nightmare it is, right? And really complex to manage. And we really want to be focused on deriving value from the data, not managing all this infrastructure. Okay, so this was the first challenge. Next slide, please. The second challenge we had, several years ago, we hired a bunch of data scientists that pretty much told us, we don't want to do anything on premises. We don't like IT. Just give us access to the cloud. And in fact, that's what we did. The problem we had with that is they were just copying a lot of sensitive data willy-nilly to any cloud that they wanted. And our costs were adding up really fast. But we knew we had to give them that flexibility, right? It didn't make sense to restrict them. But we had to do it in a thoughtful way, working in conjunction with our IT people, whose job it is to prioritize data security, create some governance around it, and keep our costs low. So this is one of the problems we struggled with. And next slide, please. The third challenge is, let me simplify the slide and basically say this. My team does not want to be in the business of managing infrastructure, right? That's not of interest to us. We really want to be in the business of transforming raw data into insights. And so that means we needed to simplify our infrastructure so we were not spending time managing it. We needed to simplify our software so we are focusing on business logic and not on how and where we deploy that software. And the last thing, those of you that do stuff with machine learning know that going from a POC to production can be a very tedious process. And Iguazio helps quite a bit with that. Okay. Next slide, please. So one of the fundamental decisions we had to make a couple of years ago is, what do? We knew being on premises with our legacy Hadoop architecture just did not make sense anymore. In fact, the only good thing about being 100% on premises was the costs were predictable over a 3-year period, right? It's a capital purchase at the beginning, and you just use what you have. So we did try to go 100% into a particular cloud early last year. It's actually fairly successful as far as the deployment goes. But the costs, the thing we struggled with was a lot of variability in costs, right? The costs just kept piling up month after month after month, and we just couldn't predict the cost. And when we dug deeper, we found a lot of it had to do with the cloud-specific databases that we were using. They're key value stores and SQL databases where the costs are a complex amalgamation of the amount of data you're storing, the number of queries, all sorts of things that are hard to compute up front. We actually did a very detailed study with one particular cloud vendor for this ecosystem, and they came up with a cost that was 7x what we would have spent on-premise. So it was just didn't make sense to us. But we did want the flexibility of the cloud. So eventually, working with Iguazio, we came up with a hybrid solution so that we get the flexibility of the cloud when we want to do POCs, dev, QA, anything that's bursty in nature. We can use the cloud very effectively at very low cost. But then we can take that same code and deploy it on premises programmatically. And to our surprise, the solution actually is half the cost of being completely on premises, right? So that's what we went with, and I'm going to describe. Next slide, please. This is, again, a 50,000-foot view of our new data platform. So we're replacing our legacy Hadoop architecture with a pretty simple, clean architecture that uses the Iguazio platform on top of our storage. So you'll notice that we've replaced the Hadoop file system with a NetApp NFS array. And at first glance, this seems like a really dumb idea, right? Why would you do this? But it turns out you can do this very effectively. The performance is fantastic. We have not actually had any performance problems since we made this switch. Also, you can turn on all the sort of native compression, deduplication, all sorts of things that go on within any modern storage array. And this is how we get a 16x space reduction compared to a 3-copy Hadoop file system. We're also able to transparently archive cold data into our object store. And there's also something called ONTAP AI, which is essentially an NVIDIA cluster that can attach to the same NFS array, right? In fact, recently we just acquired an 8-node GPU cluster on which we're going to be deploying Iguazio software. So the left side is our on-premises version, and we can essentially run the very same thing in any cloud that we choose, because Iguazio gives us that sort of cloud-neutral abstraction layer that we can deploy on any cloud on top of NetApp Cloud Volumes, which is just NFS as a service, okay? And again, we use the right side of the picture for our bursty workloads, the left side of the picture for things that run constantly. Next slide, please. So I want to dig a little deeper into that previous picture. What we do today is we take these 10 trillion data points per month and write them directly into an all-flash array on premises. And in Kafka, what we do is we just put the headers, some messages that say, I received a telemetry message and it is stored in NFS at this location, but we don't put the data in Kafka. So our Kafka cluster is actually really small. And this then feeds the Iguazio platform. So in Iguazio, we take advantage of their Nucleo sort of serverless framework, and we decompose a big data pipeline. So a data pipeline is essentially a series of data transformations. We're able to break that down and decompose it into a bunch of serverless functions. And Iguazio takes care of auto-scaling that, handling failures, and so on and so forth, right? So this has really helped us. It even helps us when we're thinking about solving a big problem. Serverless functions are sort of a natural fit for ETL, data prep, and so on. In fact, as a result of writing our legacy sort of MapReduce and Spark code as a bunch of composable Nucleo serverless functions, we found that we have 5x fewer lines of code, and it's significantly faster than before. The output of all of that goes into Iguazio's time series database. And we use that time series database to feed our REST APIs. Again, our REST APIs are again just simple Iguazio Nucleo serverless functions. We can also use it to feed our machine learning jobs. So it's pretty nice. This Iguazio database is now effectively both our feature store as well as a high-speed store to feed our APIs. And so we actually found that our new APIs are about 10 times faster than they were before. Okay. Next slide, please. So here's a summary of some of the lessons we have learned. Some of these things probably obvious to you all. Serverless functions are a natural fit for data prep, ETL, and even building APIs. We found we can build an API significantly faster when you think of it as a serverless function instead of the sort of older API frameworks. And it's also very easy for us to decompose a very complex data prep operation into a bunch of these serverless functions. And the nice thing is now we don't have to worry about where it's getting deployed, right? The programmer doesn't have to think about, am I deploying this in the cloud? Am I deploying this on premises? And here's the other part of this, right? So suppose we chose a particular cloud and used their serverless framework. Now we are forced to then use just that cloud. We can't auto deploy in any cloud that we like or on premises. So Iguazio gives us that neutral abstraction. We found that a hybrid cloud strategy led to much lower costs. Like I said, about 3 to 7x less than being 100% in any cloud. Other key thing is the separation of compute from storage, right? So if you're in any cloud, this is happening already. Compute and storage are disaggregated anyway. But on premises with Hadoop, compute and storage used to be tied at the hip. And now we've essentially broken that. We've disaggregated compute and storage. We can scale each independently. And we see a 16x space reduction with no performance impact. So very significant. And the last lesson we've learned is you need a high performance key value store, because that enables you to do some sort of interactive analysis and test your hypotheses really quickly. And that accelerates your AI efforts, right? So these are some of the lessons we've learned. Again, in this webinar, I focused on the data prep part of what we use Iguazio and NetApp storage for. I've not really focused on the things we can do with machine learning. But if there's interest, please feel free to contact me afterwards. Be happy to share what we've learned. And thank you. With that, I'll turn it back to Yaron.
Okay, thank you, Shankar, and we can move into some demo and some. Before that, let's have a couple of slides.
Yes, and we'll just have a quick poll, and then we'll go into the slides. This is our second poll now. And please let us know where you're running your AI. We talked about cloud, on-prem, and hybrid approach. We're interested to hear from you what you're doing today. So we're just going to give it a few seconds and let everyone get a chance to vote. We'll give it 5 more seconds for anyone who still wants to take part. Okay, great. Thanks, everyone. And over to you, Yaron.
Thank you. So can you move forward? Next. Okay, so let's talk a little about why serverless makes sense in those situations. So if we're looking again into what is the process, what do we really need to do once we've finished writing some code? The code could be some data analysis code, could be a training code, data preparation code, model serving code, etc. Once we finish that, we have to do still a lot of different steps, which most of them are manual and consume a lot of resources. So the first thing will be to package your code and create containers and make files, etc. And then you need to think about scaling your code, because the problems sometimes are not ones that you can address with a single container or a single function. So just like we've seen in this use case, processing 10 trillion data points, that require scaling, obviously. And scaling strategies are different for the type of workloads that we're using. If you're analyzing data, sometimes you use shuffling technologies and data partitioning. If you're handling incoming traffic, load balancing is probably the best approach, etc. The next thing is, once you build something, it doesn't always perform the way you anticipate that, and you further need to tune things, potentially introduce the GPUs where it makes sense, or cache. And we've done that in this project with NetApp team. We found some places where it just doesn't make sense to go into a database every time, and maybe you need some caching. And that's a nice thing that Nucleo allows stateful work, and you can actually cache elements within the serverless engine, and that improves performance quite a bit. The next thing that you need to do is instrumentation, meaning logging, telemetry, monitoring, dashboards, security hardening, etc. You cannot go into production without addressing those. And finally, you want to integrate that as part of a full CI process with the ability to upgrade versions on the fly, and also do A/B testing, etc. And those things are usually serverless engine. So if you think about Amazon Lambda, you can essentially write some code and click deploy, and all those things that you see here are going to happen automatically, beside the aspects that are more data oriented, like performance tuning. Lambda is actually pretty slow. But in this situation, because Nucleo is a real-time, it's a high-performance back-end processing engine, not just a front-end oriented engine, then it also improves the performance, not just addresses those situations. Another interesting anecdote that I remember working with the NetApp team is there were certain situations where we had the crashes in the functions failed because of out of memory, because someone forgot some handling some exception case, those things weren't even visible. They didn't have any downtime impact. They didn't have any impact on the overall system, because that's the real advantage of microservices. If a function fails, it crashes and it restarts again. Traffic goes back into the system through the load balancers, and things keep on flowing. And this is really the key advantage of breaking your big monolith application into small things. We only saw that in monitoring, and after a while we said, oh, you know what, there is probably a bug in one of the functions that has some sort of consuming too much data or has some bug in the code. So that's another interesting side effect. And by moving into this architecture where all this automation happens, you can actually focus more on developing your work and building the business logic. Next. Now, serverless is usually confined to those use cases of front-end application, again, HTTP workloads, etc. But one of the things that we've done on Nucleo and sort of the accompanying project MLRun, which is more of an end-to-end orchestration project, is broadening the scope. Instead of thinking of serverless just as an engine for processing events, we can actually process various workloads. We can do distributed training. We could do distributed data processing. We could serve models in an easy way. We could ingest data from streaming or do batch ETLs, all using the same framework. So, and now once you build this microservices, those small, tiny things that do one thing very, very good and very, very fast, you can assemble pipeline by just chaining those into one bigger picture. And those things have to have state. The biggest problem of most serverless technologies is stateless. And what Nucleo allows is essentially mounting on state, mounting on NetApp NFS volumes, and mounting on a database, etc. And this is really the thing that allows you to build, create sort of a data lake or whatever, and have a lot of microservices crunching data on top of that distributed data lake. Another major advantage working with NetApp is that the storage layer is federated. So essentially, one of the great things here is that I could build two clusters. One is on-prem, one is in the cloud, and both will have the same data because the NetApp replication engines, they know how to move data back and forth and synchronize it without doing anything on the customer side. So you can actually create two clusters which are identical on both ends of the globe. Next. So this is just an example of the value of serverless. This is using Nucleo, but again, there are multiple serverless engines in our framework. Nucleo is more of the real-time, sort of high-performance, pretty swift engine. And what you see here from a benchmark that we've done a while ago is that you can take your Python code, and the same exact Python code will run 20, 30 times faster because of the real-time parallel processing framework of Nucleo, which knows how to essentially do sort of cloning and threading over your code and do parallelism of your code within the function. So that means that you don't even need to translate your code to something like Java or C and waste a lot of resources doing that. You can actually take your own data science code, harden it a bit, add exception, add some telemetry potential and logging, and that's it. It's ready for production. And all those other things that are code to production, meaning Dockerization, performance optimization, logging, scaling, all those things are fully automated. You don't need to think about those, as we'll see in a second. And it's extremely high performance. Other aspects or advantages of sort of this function-oriented architecture is now you can build pipelines by just chaining multiple functions into a graph. Or you can just create a function, document it, store it in a repository or a library, and then just pull this function, change parameters, and off you go. You don't have to rewrite everything over and over. You can componentize your work, your monolith, and then reuse it in different use cases. Okay, and next. Okay, so let me show you a couple of things. One, I want to show you essentially how the integration with NFS works, which is pretty sleek, and then I'll show some more example of how to work with the serverless engine. Okay, so What we see here, this is the NetApp Cloud Volume Framework, which is pretty cool. That's in the cloud. So you can essentially, if you have a NetApp account, you could just go to the cloud and you could build volumes in NFS. And then you could just log into the Kubernetes pane, identify the cluster, the Kubernetes cluster, and because we're running on a Kubernetes cluster, you can actually go into the specific cluster. And within that cluster, I can create volumes and mount those volumes into my cluster. So essentially, think of that very flexible sort of data lake that I could just create a volume on NFS. By the way, I can take the same volume and mount it to multiple clusters or on-prem with replication, etc. And just create this volume. I can snapshot the volume if I need to. I can do all sorts of storage management things on that volume. At a certain point, I want to use it in our framework. So what you'll see in a minute that essentially I can go in and create, this is the Iguazu dashboard. You could see the different services. So for example, I'm going to a Jupyter notebook, and in the Jupyter notebook service, you see it has a lot of neat features, like it's auto scaling. You're not using the Jupyter, it's essentially killing itself, snapshotting all its data on the NFS volume. So you don't really have to keep the, wasting energy. You can put CPUs, GPU resources, memory resources, security credentials, and you just specify the volume mounts. This PVC that we just created on the NetApp side, we just mount it into our Jupyter notebook, and that's it. And then we just click saving the service. And at this point, when we go into Jupyter, I can just do an LS or whatever, and my notebook has access to a huge amount of data without doing anything, beside what you've seen here. So it's pretty neat. And beyond looking into mounting it into the notebook, which is nice, we can also mount it into a function. So I can go to Nucleo. This is the Nucleo. Nucleo, again, is open source, but is also packaged as part of our managed platform. So I could write some function. I could do it in the notebook, as we'll see in a minute, or I can do it in the Nucleo dashboard. This is like a sentiment analysis function. I could give it, I've written here something, let's test, it's actually analyzing my sentiments. I see everything. So it's pretty cool. And then the way that I can have this function just mount over NFS just by mounting a PVC. So, this is sort of a pretty naive code, but you can build something bigger, like what Shankar team did, which is essentially getting a notification about the file, and then the file is already in the file system, unlike S3 or object that you actually need to load the file first. Here it's already there. You just need to open the file, crunch it, and do something. You don't really move the data, which is pretty cool. And you have a function up and running. And if you want to trigger the function from, let's say, Kafka or Kinesis, you just specify a trigger, specify the address for your Kafka topic, and that's it. So I can have my code listen on a stream. And also, as we mentioned, there is extreme parallelism in Nucleo that is going to run extremely fast, even though it's Python code. So that's on that front. But let's go back into a notebook. How do we create those functions? So as we mentioned before, we want to write something simple. The data scientist knows notebooks, he knows Jupyter. So you can actually go and write a function within his notebook, and you can specify parameters in his functions. You can specify, put documentation to his function to make it very clear. This is an example function that opens an archive, for example, from an S3 URL and writes it into NFS. It unzips it into NFS. So this small library is doing like unzip, and it's sort of writing it to the destination. It's also using the artifact tracking mechanism and experiment tracking mechanism. So it logs the information about actually where it placed the content. It could be used very well in a pipeline. And then the next thing we can do is just create a function out of it. a function object. That's the only thing we need to do. The nice thing you can see, it's also addressing documentation. I can add descriptions, categories, and all those things, which will essentially go later into the function marketplace, where I can just search functions by category, etc. And then I can just go and export or upload the function to a database. When I want to use a function, I can just go and import the function from a file or from a marketplace. I don't know how to use it. I just pull in the documentation for the function. This magic server was created directly because the engine here, the SDK, knows how to parse my documentation and makes it something that could be used in a UI or API. And then I can just go and execute my function locally. So that means I'm just running, I'm loading this function, I'm running it locally. Okay, that's pretty nice, but now I want to run it as a distributed cluster job. So I need this job to mount over the same NFS volume. So essentially I'm going to say mount PVC, and I have this basic PVC that we created. And I'm just going to run my job. This will actually go and create a pod on Kubernetes. It will distribute my job. It sees that like as if this function was running on my notebook, but it's actually running on the cluster and using NFS as a way to pass data back and forth between my job and other jobs, or my Jupyter notebook, which mounts on the same volume, to that other function. So this is one example. Obviously, we can have way more sophisticated function. This is like a machine learning validation function from the library. And we can look into real-time functions like this XGBoost serving function, which is another nice thing is that in the notebook, I can already annotate my code. I can say, you know what, I really need those packages, NumPy, XGBoost, in my container. And then I can write this function, which is a serving function. So it has a load and a predict calls. So load will be called once in order to load the model, and predict will be called every time there is a prediction request. And then I could just go and deploy. I can test my function locally, say that it works. And then in order to deploy it, I can just go and deploy my function, and it goes into the cluster and runs and does serving on a live fashion. So I can just go into the projects, for example, it's this one. And I could look into this function, which is running live. It's doing the prediction, and it's connected to data or streaming. By the way, if I want, I can even connect it multiple functions to the same API gateway and create canary deployments for a production. I could just go and say, you know what, I have two functions, but 40% goes to this one, 20% goes to this one, etc. So you could build very powerful layouts by just, you see, writing some notebook code, you're clicking deploy, and off you go, it's running in production. So this is the experience that you're seeing that you don't, if you think about it today, people write huge notebooks and then it takes a huge amount of time to refactor it into microservices that will go into sort of a production pipeline. Here you could just go and write it in a notebook, publish it, let other people work on it, and then just deploy it in production. You could do more complicated things like building a full pipeline. This is for an integration with Kubeflow. You can essentially chain multiple functions, one to the other. And for example, this is like doing ingestion and then doing analysis and doing training and building model serving. You just specify the different functions, you connect them together, like the output of one goes to the second. This is like an AutoML function that takes a data set that was analyzed and running various scikit-learn algorithms on that to find the best model that generates the best accuracy. And once we have that, we can just go and deploy. And that's a relatively easy way to combine multiple functions in a single pipeline. If you want to look how it seems in the pipelines, which is based on the Kubeflow pipeline engine, let's take this one. So you can see essentially this entire flow that I'm building of, for example, one step is getting and analyzing the data. The second one is doing training and generating all the information about the training as well as the model files. And then I'm deploying those model files. And I could even go and further test my model once it's already installed to verify that the performance of the model is adequate. And I don't want to be surprised in production. So you can see that you have a full flow from developing something in a notebook, playing around with it, publishing it on a cluster. And by this combination, working with NetApp, you can have a huge data layer underneath with all those advanced capabilities of snapshotting, replication, synchronization between clusters. All that is pretty integrated and neat. Okay, so with that, any questions or?
Okay, great. And we do invite you to join our MLOps Live community on Slack. Right after this webinar, we'll be holding an Ask Me Anything session with Shankar and Yaron, and you can continue to ask questions there. So we'll just take one or two now live, and at the end of this presentation, we'll be moving over to our Slack community. So the first question is there an option to split the traffic to more than 2 endpoints for testing?
Yeah, so I essentially just want to replicate the same traffic to 2 different locations. Yes, it is possible. And by the way, because the functions are really fast, then you could take a function which will become sort of a routing function. This is something that we're doing with ensembles when you have multiple models that you want to serve, and there is a business logic for the ensemble itself. So it may actually be multiple functions where one is sort of the front end that builds the ensemble, and you have back-end functions that are one for every technology. Like TensorFlow will be one function because it's very unique to TensorFlow, and like XGBoost on a different one, and ensemble in the front.
Excellent, thanks, Yaron. And the second question is, can you deploy Iguazio anywhere?
That's a great question. So Iguazio can be deployed on 3 different options. One is the SaaS option in the cloud. So we manage the infrastructure. Another one is what we call PaaS. So you can have your own Amazon, Azure, etc. account, and you just run sort of an installer that installs the Iguazio integrated platform into your VPC. And the third option is on premises. This is where we have partnerships with companies like NetApp and others that bring the full story together with the storage and global support and all of that, so you don't have to have a lot of hassle deploying and maintaining that.
Excellent, thanks, Yaron. Okay, so we'll just have 2 more slides for you, and then we'll be moving over to Slack. So we just wanted to invite you to learn more about MLOps and about our partnership with NetApp on our website. We've got lots of resources, blogs, videos. We have videos from industry experts from Netflix, the New York Times, Uber, and many others presenting their insights and best practices on MLOps. We also have the previous sessions of the MLOps Live webinar series, which you can watch on demand.
So I just saw a question on chat.
Yes, let's see that question here.
I said, was you been tested with Azure NetApp files as part of cloud environment?
Cloud environment, yes.
Yeah, absolutely. You can run Iguazio with Azure NetApp files or cloud volumes with Amazon and Google. And we actually do this today. All our QA runs in that environment.
Thank you, Shankar. If there are any other questions, please feel free to add them in the chat.
Can you share the link of the Slack workspace? I see a message.
Yes, we'll share it in just a moment. And you should have it there in the chat now. It's the link that says App Slack. There it is again. Great, so we'll be moving over to Slack momentarily, but we just wanted to mention that we'd love to have you join our next session, where we're going to be hosting Greg, Ecolab's Data Science Director, for a talk about breaking the silos between data scientists, engineers, and DevOps with new MLOps practices. And if you have any comments or feedback about today's presentation and what you're interested in hearing about next, we'd love to hear from you. You can just email us and let us know. And I wanted to thank Shankar and Yaron very much for this great presentation. And we now invite you to join us on the MLOps Live Slack community for a continuation of the Ask Me Anything session. So let me just see if there's another question. No, just great session. Thank you very much, everyone. So we are moving over to Slack.